All right, so welcome to the second section of the unit, and we're going to be talking about how you interpret graphs and stuff. And this comes really handy in science when you're having to make your graphs based upon your variables that you have and the data that you end up collecting. All right, so number one says Jenny leaves home and drives to the beach. She stays at the beach all day long before driving back home. Which graph best represents her day? All right. So with that said, the steps to being able to solve a problem are understand the problem. So we need to understand what the question is asking and what the information is being given. We need to make a plan on how to figure that out, and then to solve it, and then look back and see if we have made our graph right or interpreted it right, and whether we've been able to come up with the results based upon the information given. Okay, so you have to have evidence to show your answer. All right. So there may not be work here, but you have to be able to explain your answer, is what I'm saying. So if you think about it, it says that each of these graphs, each of these three graphs, are the time is 0 here. All right. So think of that as the beginning of the day, and then when she gets home is here. So this is like the end. All right, and then if it was a certain amount of time, that would actually be the end time. All right, and then distance is the distance from home. So this would be 0 to how far away she went. So what you're trying to figure out is how her day would look on a graph. So she started at home, so therefore our graph should start at 0 because that's how far away from home she is. So 0 should be where it starts. This does not. This starts as if she started her furthest away from home on this graph right here. So therefore this graph cannot interpret her day automatically. But if you were to look at what it says, this would be as if she started from home, went somewhere closer to home, stayed for a while, and then eventually came back home, or eventually came home. So it'd be like if you stayed over at a friend's house, then went over to another friend's house, stayed there all day, and then came home. That would be like how you could write your graph. So the other two graphs are going to be what you need to look at. So what you got to think about is all right, this graph is saying that she drove somewhere and then drove right back. She didn't stay at all. She just drove somewhere and turned right back around. Because time says that she didn't stay anywhere. Time just says that she drove away from home and then drove back home. There was no time spent. So this leaves the only one that it could be, because therefore you start at home, you drive somewhere for a while, so you're furthest point away from home. You stay there, so you're not driving anywhere. Your distance is not changing. And then you drive back home. Now, thinking in science, all right, you have a problem or you have a hypothesis that you're trying to prove. So the data that you collect, you could put into a graph. All right? So your y is going to be your dependent variable. It's what's changing as a result of your independent variable, the thing that you don't want to change, okay? Or the only thing that you are changing. I apologize. So the independent variable is your x, which is down here. Think of this as the x-axis, and the y, which is your dependent variable, is up here. So over time, distance is changing. All right? So that's what you think of. Time is what we are changing, and as a result of time, our distance changes. All right? So when you're in science and you have to graph something, your independent variable goes on the bottom line, and your dependent variable goes on your vertical line. Okay? All right. So work out the practice problems. Come in tomorrow with any questions that you might have, and we'll go over this tomorrow.